Students, we are here for the third session with Madam, and things are almost ready. So I hope that you will get the maximum, and in the end, you can ask your doubts, etc. And when we were taking lunch, I was discussing with Madam that if possible, please share some more examinations, competitive examinations with us so that we can participate in those competitions also. So I think I have given the hint to you what things you have to ask in the end. Right? Best wishes.
Copy down those problems here and I think you must be ready with solutions. Correct? This is it. You want some time. Okay.
Can you write the first word here also?
Yeah, I will write. So we have a circle with diameter 18 and radius is equal to 5. And O is the center. And suppose P is a point on the horizontal. Then why still there is some question there? Please. Okay? I know you had your lunch. Okay? Now, bed. And let AB be diameter and PB distance is equal to what? Radius of the circle is 30. We call a chord as an integral chord.
कुछ नहीं लिखा है।
I think it is taking little time. We'll wait. Depends on inclination. Show me the visual effect. Integral chord if its length is 8. Okay. Then find the number of integral chords to P. Pictures of. Okay, I think I have to go back to then. Very sorry. Okay. Very sorry. Can you see that? Yes. That code is visible to everybody? Yes. Chalo, at least we have this code. Okay. So, we call the chord integral if its length is an integer. Okay. Follow? And find the number of integral chords through P. So every chord need not have integer length. Okay. We call a chord integer if it has integral if it has integer. So we need to find the number of chords through P which has integer. Okay. This is first question. Second question is that we have 2003 points in a plane. No 3 are nonlinear, no 4 coincident. Means no 4 will lie a circle. Then we want to prove that there exists a circle with 3 points. Okay, out of this. Okay, and Sanjay remaining 1000 point in the interior and 1000 point in the exterior. Okay, these are two questions. Is there anybody who has finished both the questions and I will give the third? Okay. Want me to give hardcore geometry? If there exists a circle, you might see that. Should I increase the point? That will be done. Okay. क्या मतलब है मेरे यार
और एक ये
Are we ready?
क्या
Yes, anybody got the answer? Anybody got the answer? Yes. Suppose I want to find out the length of the largest chord passing through P. What will be the length of the largest chord? 26. So largest chord is diameter. So its length will be 26, correct? What will be length of the smallest chord? So we claim that
That's 5.
5 to 10. We assume it's a smaller. We'll prove that it is the smallest chord. Right now, we consider a chord CD, which is perpendicular. Okay. Then this is 13 and this is 1, so this is 12. So I know this is 5. And because of symmetry, this will be 10. Right? Okay. So I will get length of the largest chord is 26 and I claim that CD is the smallest chord.
पीछे कर दीजिए हाँ किसका हाथ है
And its length will be 10. Okay?
हमारे पैर लग जाएंगे ले सर
So I need to prove that this is the smallest chord which I will prove. But if I have a chord of smallest length 10 and largest length 26, so how many such chords will be there? Because this is a circle, chords of all sizes will be there, correct? So chords starting from 10, 11, 12, so on till 26 will be there, correct? But only thing is, suppose I have a chord whose length is 11. Okay, suppose PQ is a chord with length 11. Then I can reflect this because AB will be axis of symmetry. So P dash Q dash, what can you say about PQ and P dash Q dash?
11.
They will have same length. Correct? So I will have for all these lengths till 25, there will be 2 chords each. Correct? Followed 2 chords each. What can I say about 26?
Only one.
Only one chord AB. Correct? What can I say
Yes.
about CD?
Yes.
One, because if I reflect, D is a reflection of C and C is a reflection of D. So CD is a reflection in DC. So here one chord and here one chord and rest 2 chords. So how many now you count?
32.
30. So total number of integral chords. Okay. Only thing is left to us to prove that CD is the shortest. Okay. How can I prove CD is shortest? Okay. So for that, let us consider one more chord to it. Some other chord other than C. Pick it. Okay. Sorry, P I have already taken. So call it Q. This is Q. Here also I am going to take it R. Sorry. P I have already taken the point. Okay. Huh? So let O be the center. Okay. So I know that the okay. Now among OP and OM, which is greater?
And so RMO will be also 90 degree. RMO.
Sorry.
RMO angle.
R and O will be 90. Yeah. M is midpoint. We know segment joining midpoint of the chord passes the chord. Correct? Okay. Okay. Midpoint and center of the chord passes the chord. Correct? Okay. Now, sorry, perpendicular from center passes the chord. Okay. So M is midpoint of RQ. Okay. We write usually M is midpoint of RQ like that. And we know T is midpoint of C. Correct? This is symbol use. Huh? Okay. Now, which is greater? Tell me, OM is greater or OP is greater? OP is greater than OM. Correct? Okay. Now, what can I say about OR and OC? They are radius, correct? They are
Yes,
both
ma'am.
radius, correct? Now, therefore, CP is what? CP square is equal to R square minus OP square and C and RF square is equal to R square minus O square. Correct? By Pythagoras. Right? So now I know OP is greater than OM. So among CP and RF, which is greater? RF has to be
RF.
greater because I'm subtracting a small. So RF has to be greater than CP. So that means 2 times RF, which is RQ, has to be greater than 2 times CP, which is CP. Correct? Is that clear? Any doubt, anybody? Should I explain once again? Or is it clear? Anybody wants me to explain once again? Okay, so we have proved that this is the shortest chord and therefore total number of chords will be 30. Okay. 33, one.
And so total number of chords?
32. Because 15 2s are plus 2. Because there will be unique chord of length 10 and unique chord of length 26. Okay? Any doubt, anybody? 32. Because one chord of length 10, one chord of length 26, and two chords of each of this length. These are 15. So 15 twos are plus 2. Okay? Is this clear? Any doubt? Okay. Now, going for the second problem. So may I erase this? Now, okay, third problem. Suppose we have a 100. A second problem we will discuss. Till then, I'll give third problem so that, or we should first discuss second. Okay. Should I discuss second problem? Everybody is ready?
Yes.
Okay. Now, I hope everybody knows the property of circle that this measure of arc, everybody know this? A major arc AB is supposed to M. Then what is this angle? M. Everybody know this? Is there anybody who doesn't know this? Okay. Okay. Yeah. So see, what you mean by angular measure of the arc is the central angle associated. Okay. Then if I take angle here, it will be exactly half of this. This is a property. Okay? It can be very easily proved, but right now you please assume so that we can understand. Now, so suppose this is my center, but I'm not taking angle at center. I'm taking angle at some other point P. So my chords are okay. This arc's major is 12 and this arc's major is 12. I need to find this angle theta. Okay, I need to find this angle. Now pay attention. How can we do this? We will draw this. Now what can I say about ACB? This angle will be M. And what can I say about DBC? This angle will be N. So what can I say about this angle? M plus N. Okay, exterior angle of a triangle. Everybody know that? One. Suppose this is equal to 12 and this arc is 12. Okay, I need to figure out this angle. Okay, this arc is 12. I need to figure out this angle. Now it is in the exterior. Okay, so for that, let me join this. Which angle I know now? Do I know this? How much? M. Do I know this? How much? N. So what is this angle?
M.
M minus N. Correct? Can you see that, everybody? Now these are very important properties. Okay? In geometry, in cyclic quadrilaterals and angle chasing, we use this every now and then. They are very, very important properties. Okay? Now, so if I take a circle and if I take some arc, okay, then if I'm making one angle in the interior, one angle on the circle, and one angle in the exterior, okay, let me call this alpha, let me call this beta, and let me call this gamma. Okay, tell me which one is greatest and which one is smallest.
Ma'am, alpha is greatest and gamma is smallest.
Everybody know that alpha is greater than beta is greater than gamma. Correct? Huh? Now, this question is based on only this property. That's all. Okay? Only this property, that's all. So what we do here is, I have 2003 points in the field. Okay? And no 3 are collinear, no 4 constant. So what we will do is consider the set of 2003 points. Okay? And imagine a line far away from this. I'll shift this line, I'll bring it closer and closer till it meets the first point on the set. Okay? Then you tilt the line till it passes through the second point of the set. So I have a position now that I have 2 of the points, say AB, on the line L and rest all points on the other side. Correct? Can I achieve such position? How many points are here?
2000.
2000. So what I want is, I want 2 points on a line and rest all points on the other side. This much is clear? Now, can I say some 3 points, some point P1 also lie on this line? 1.
And because no 3
No 3 are. Correct? Okay. So now we are interested in finding angles theta r, theta, which are defined as A, P, I, P. What I mean by that? That means theta 1 is angle A, P1, P. Theta 2 will be angle A, P to P, and so on. Okay? Follow? Then, what we can do? We consider all such thetas. And let us arrange all thetas in increasing order. Theta 1, theta 2, theta 3. Suppose we are arranging theta 1001. It might happen some of the thetas are equal, right?
Yes, ma'am.
Huh? Some theta might be equal. Still, suppose let us assume that A, this and this, suppose these are equal angles. Okay, some theta x is equal to theta 1. What can I say about these 4 points? They are consecutive. If theta x is equal to theta y, implies A, px, py, b are cyclic, correct? Is it allowed?
No.
Is it not possible?
We're constantly.
Concyclic means they lie on the same circle. Okay? Or cyclic, you can say anything. Huh? So, no 2 thetas are equal. So, you get strict inequalities here. Correct? Okay? This much is clear? What? Sorry, I mean, it is not necessary that my thetas are in this order. Okay, it is not necessary my thetas are in this order. What I will do, I will rename the points so that theta 1 is less than theta 2, theta 3, and theta 2000. Okay, what I am doing? I will relabel the points. Points are there, I am not labeled. So I will label the point in such a way that P1 is such a point that A, P1 be smallest angle, next smallest is A, P to B, like that. Can I relabel the points? Okay? Followed?
Yes.
Is this clear?
Yes.
Any doubt, anybody? Wonderful. Then, middle point is theta 1001, middle angle. So we have 1000 angles less than this, correct? Now on the circumcircle of A, B, and P 1001. In circle passing through which points? A, B, and P 1001. Okay? Okay? It is a circle passing through A, B, and P 1001. Now, so what will happen to point P1? P1 has angle less than this, correct? Theta 1001. If P1 is less than this, so where the point P1 should be? Outside the circle, correct? Because this angle is less than. Can you see? Correct?
Yes.
What can you say about P2? P3? Till P1000. So that implies points P1, P2 till P1000 will lie on outside the circle. What can you say about P1002? Its angle is greater, so it has to be inside the circle. Correct? Followed? So P1002, what about P1003? So until P2001 will lie inside the circle. Correct? So we have exactly 3 points. Which 3 points? A, B, and P 1001 on the circle. Then P1, P2, P1000 points outside the circle, and P1002 to 2001 1000 points. Okay, is this clear? Yes, because if two angles are equal, okay, then it is well known property that if two angles made here are equal, it is a sine. And no 4 angles. Okay, any doubt, anybody? May I erase this? Now let me give you one easy problem which can be done without much knowledge. What we can do is, suppose we have a polygon with 100 sides. And with some, say, 200 points in the middle. Such that no 3 of these 300 points are floating. Okay? Followed? I have to cut this into triangles. You have to cut it into triangles with. Suppose this is made up of paper. Suppose this is all the paper. So I have this a polygonal paper given to you. Okay? Into triangles with vertices of each triangle are from this 300 points. Find the number of triangles. Maximum number, sorry. Find the maximum number of triangles that can be formed. is called triangulation. Now, let me give you an example. This is an easy way to deal with any difficult problem. Take a small example. Okay? Especially number theory and combi we do that. Take a smaller example. Okay? So here, suppose you have 4 points as vertices and 2 points in the interior. Correct? Pick. Suppose. Okay? Then what I want to cut it into triangles. So how many such triangles maximum will be there? And then all the vertices of any triangular piece should be from these 6 points. No better. Because problem is that if I draw something like that, then I can't draw this again. Because then this will be extra vertex. Can you see that? Which is not from the 6 points.
And so 6 triangles.
So in this case, there are 6 triangles. So what we can do is we can only draw two segments which are not intersecting in the middle. They will intersect only at the vertex. Understood?
Ma'am, so the number of vertices is equal to number of triangles formed.
No. In this case it is, but every time it is may not be the same. See, you can't every time generalize. Let me do a generalization. Okay? 3 is a prime. 3 is odd or even. 5 is a prime. 5 is odd or even. 7 is a prime. 7 is odd or even. 11 is a prime. 11 is odd or even. I can give you example of infinitely many primes, and all of them are odd. So I make generalization. All primes are odd. Correct? So there is one hidden somewhere which will contradict my statements. So even though my statement is true for all other primes, one number is sufficient to contradict. So while generalizing, you have to be very careful. Okay? You can take one more point and check how many triangles you are getting. Actually, your hands. I'll show you Pascal's solution. It's very nice. You know Pascal's proof? You know synthetic proof of Pascal? Out of 3. Unfortunately, I don't know whether it's available or not. Usually they give Seva Minute. I have done proof using.
And there are 9 triangles. And there are 9 triangles.
Unfortunately, it's not easy because we can't select all. Unfortunately.
Ma'am, if we add one more point here, the triangles are coming 9.
Triangles are coming 9. So it is not number of points and number of triangles, right?
So
If you add one more point, then how many triangles you are getting? Add one more point. Here you are getting 6. If you add one more point, how many triangles?
नहीं भाई इधर बैठने देखने
Yeah, but you can see here, I can't choose PQ and D. Can I choose PQ and D? There's a configuration issue here if I choose PQ. So, see, that would have been number of triangle which I can draw. Once I cut, then it won't be choose. Huh?
Ma'am 10.
10. 3 points. तीन एक सेकंड कितने
नहीं
पॉइंट्स
4
में
points.
4 पॉइंट्स में 10 ट्रायंगल कैसे मिले मुझे
Ma'am ये देखो.
नहीं 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 हाँ 10 करेक्ट या या 3 पॉइंट्स के लिए 8 4 पॉइंट्स 10 करेक्ट 5 पॉइंट्स 12 करेक्ट लेट मी कैलकुलेट
Always. Then an app.
Yes, that's your guess is your guess is correct. Now prove it combinatorially, prove it geometrically. Have a geometric solution for it. Okay? Till you are solving, let me explain little bit about RQM exam and how to crack it. See, RQM exam have 30 questions. Okay? What was last year's IOQM cutoff?
20, 26 for boys and 24 for
नहीं वो बाद
girls.
में reduce किया ना 25.
20. Okay?
25.
Out of 100 marks. Okay?
मैं 30 questions नहीं थे.
Every year it's always 30 questions.
Ma'am, it was 25 for boys and 24 for girls.
Okay.
26 था.
Right. Okay. Before that cutoff was 11. Last to last. 10. Okay. So cutoff goes down. Okay. So do I have to solve each and every question? No. Believe me, nobody will be able to solve each and every question in that 3 years. Because last 5 markers are quite lengthy and big. Okay? But if you have done a similar problem, you might find 5 markers easy. Okay? Up till now, I don't know. Not because they are not capable, because lack of time. Okay? But that's why what 94 he must be one of the team members. Okay? Yeah. Okay. So that's okay. There are some rare cases. But what you have to do is you have to just clear the cutoff. So focus on what you know rather than what you don't know. Okay? Followed? Okay? So best policy for you is combinatorics and algebra. So try to solve that maximum. Okay?
And ma'am you suggested songs.
Yeah, I will suggest one more book for basic combinatorics. Okay, I'll show you books in my laptop. Okay, and I'll tell you exactly what to be done from that books. Okay, according to your levels, because this is a mixed class, so accordingly I'll have to give you the advice. Okay. Unfortunately for algebra, I have something. Except excursion in mathematics is very good for algebra.
मालूम है आप excursion. बहुत अच्छा है.
TJB's functional equation is there. TJB's book will be cut for the viewers. Yes. 490. Very good. Okay. So how you got it? Yes. How you got it, beta? It's okay. You can explain in your own language. I know it's very difficult to explain for me. Acha, okay. Acha, okay. So it is a guess. Okay, but correct guess. Good for argument. You have concrete reasoning for okay. So let us do divide and rule. This is my favorite policy, British policy. Divide and rule. It works. So what we will do is out of 200 points, first take one of the perfect. Okay. Okay. So when I take P1, how many triangles I will get? Let me write stats here. P1 will create how many triangles? If I drop only P1 in this, how many triangles are there? 100, correct? For each side we will get one triangle, correct? Yes. This will give me 100 triangles, correct? Right? Okay. Now let us add P2. Now there are two chances. P2 can be one side or it can be in the interior of the triangle, right? Yes, because no 3 of 300 points are collinear. So this possibility is not possible. So P2 has to be in one of the triangles, interior of one of the triangles. Now I need to cut this triangle. How many more triangles P2 is adding? 3. Everybody agree to that? Because P2 can be joined to which all vertices? Only these three vertices, correct? Can I join P2 somewhere here? Can I join P2 like this? No, because then this will be extra vertex. Correct? So P2 is giving me how many extra triangles? 3 extra? 2 extra. Why?
Because 3 will form
Yeah, one triangle. This one triangle, suppose this is A4, A5. Okay, P1, A4, A5 got cut now. It was counted here, but it got cut, and I'm getting 3 instead of that. So instead of 1, I'm getting 3. So 3 minus 1 is equal to 2 extra triangles. Correct? Huh? Done? Now take P3. P3 will lie somewhere either this new triangle or any other triangle. How many extra triangles P3 will give? 2. Correct? P4. P200. Okay. So what is your total? 100 plus. Okay. This is called counting. Okay. We have counted. Now let us see one elegant solution, geometric solution to this.
But how does it define that it is the maximum? I had the same.
This is the only possible. This is the only possible. There will be unique solution. Yeah, because I will prove it geometrically also. But check. If you put 1 point, you are going to get 100. Correct? Every extra point is going to give you only 2 triangles extra.
But we have joined P1, P2, P3 and then some other arrangement tables. Why is it that we have to join?
For any arrangement, you have any arrangement.
But why is it that we have to join P1 to all the vertices? Why is it necessary?
Okay, yeah, you are right. You have got a point. Okay, so that I will give a combinatorial proof. I don't have a combinatorial proof for maximum. For that, I will give geometric proof. Okay, now, so assume we have T number of triangles. Suppose number of triangles will be let okay. So this is my A1, A2, into polygon, and these are my points. Whatever given me, whatever points that I have created some mess, and suppose this is the arrangement that gives me maximum number of triangles. Okay, suppose this is the arrangement that gives maximum. Huh? Okay, I will assume that it is triangles. Huh? Okay, number of triangles. Okay, this much is clear. Now, what I will do is I'll count angles of these triangles. Okay? So I have T triangles, so I have 180 T angles, correct? For T triangles, sum of all angles should be 180 into T. This angle involve all these angles of polygon, correct? What is sum of all these angles of polygon? Huh? 180 into n minus 2. Everybody know that sum of angles of n side and point. So that is 98 into 180, correct? Hmm? Now, at every point, what is the sum of angles? 360. How many points are there? 200, correct? So divide by 180. So T will equal to 98 plus 2 into 200. Right? Okay? Is that clear? So now this can work for any arrangement. This proof I have not used the maximality of arrangement, correct? So this proof works for every arrangement. So for any arrangement, I will get 498 triangles itself. I've just given maximum to fool you. Okay? So that you should go into some other direction and pick. Okay? Is this clear? This technique is called double counting. What do you mean by double counting? I am counting angles in two ways. How? Once I counted using triangles and once I counted using angles of polygon and interior points. And double counting always ends up in giving some nice equations or inequalities also very beautiful inequalities. Okay? Huh? Okay, so in this problem we have seen what you will learn from this in combi and NT problem. This is a technique that works many times. Divider rule, take one point at a time. Okay, and double counting, if you can do double counting. I'm not sure. Okay, huh? Then that also comes. Okay. Any doubt, anybody? Hmm? So let us go to the next. You have 2 minutes.
मैं डॉक्टर नहीं आगे सुबह कट कर
One easy question again. Just stop. Maybe I okay. One easy one. Okay. One from the okay. Suppose we have a couple called Mr. and Mrs. Smith. Okay. And they invite four couples for dinner. Okay. Four couples. Okay. So we have Mr. and Mrs. Smith.
Mr. and Mrs.
Smith. अच्छा क्या?
मैम हम इंडियन से
Mr. and Mrs. Gupta. Smith.
And we have plus four couples. Okay? So some are friends of Mr. Smith and some are friends of Mrs. Smith. Okay? So when they arrive, those who know each other shake hands with each other. Okay? You already know this problem.
They ma'am, similar type of.
Probably you know this, you just wait. Now, so you can solve that Kane problem. Okay? Kane. Completely. Okay. So, you will enjoy it, I promise. When I give the solution, you will definitely. So, we have four couples. Okay? And we have four couples. Okay? Some are friends of Mr. Smith and some are friends of Mrs. Smith. And those who know each other will shake hands with each other. And those who don't know each other will just greet each other. Good morning or good night. Or dinner if they meet. Okay? Not good night, good evening or something. Now what happens? There are totally 10 people, including Mr. Smith,
Yes.
Mrs. Smith,
Four.
and obviously no couple, no spouse shake hand with each other. Okay? Followed, no spouse shake hand with each other. Okay? You already know the problem? You already know the problem? Wait. So no spouse shake hand with each other. Now, here we have 10 people. So Mr. Smith is observing, and apart from Mr. Smith, we have 9 people, right? Okay. So Mr. Smith has observation that each of these 9 people have done different number of handshakes. Okay, all these 9 people have done different number of handshakes. So what are information we have? We have information that there are 10 people, out of which 9 people have done different number of handshakes, and no couple will shake hand with each other. 3 information. Using this 3 information, we have to find how many handshakes are done by Mrs. Smith. Believe me, this is not any stupid problem. This is proper mathematical logical problem. I will prove. Of course, I have a proof. Otherwise, I would have not given them. Wait. You should not give away answer. Wait. Let them think. What? Yeah, I know. Graph theory basic. What else? And
अरे मैम का ऐसा हाथ ऊपर करो जो और इधर नहीं हाँ
okay. So can I do something on told me?
मैम अंजू बोला
Told me?
First this question.
yeah
Algebra you want? Okay.
बंद में
They might be. Some of them might be common. Like I don't know all friends of my husband, but I know some of them. 90 or something. Any combination. So for any combination, any such combination, there is unique way to find out the number of handshake done by Mrs. Smith. Okay? This is a strength of mathematics that we can find this out. So can I give one nice problem on Ptolemy? Everybody know what is Ptolemy's theorem? Ptolemy is done in this class? Alright, wonderful. Okay, I will start. I will revise Ptolemy. We have a hexagon in which three sides are equal. Okay? AB is equal to BC is equal to CD. DE is equal to AF is equal to AF. Also, these angles are 60 degrees. 60 degrees. Okay? And we have 2 points in the interior section.
मैम angle DEF होगा ना?
DEF. Sorry. Thank you. Acha, okay. Yeah. Angle CHD is equal to angle AGF is equal to 120 each. Then prove that CH plus HD plus HG
मैम HD
HD
हम कपल से शीट
plus HG plus AG plus FG is greater than or equal to P.
हम कपल से
Okay? Ptolemy's theorem if you want.
Ptolemy से
In a cyclic quadrilateral, actually AB into CD is plus opposites, product of sum of product of opposite sides is greater than or equal to product of diagonals. But if equality holds, if and only if quadrilateral is cyclic. Okay? Okay, this is Ptolemy, and I promise I've just used Ptolemy in this. Of course, not just Ptolemy, but with Ptolemy something else.
So how we
Okay,
will, ma'am,
I'll give you a hint.
how we will solve that question?
Using Ptolemy.
कपल
Achha, couples will happen. Okay, I'll give you a hint. Suppose this is equilateral triangle and P is any point here. Suppose this is equilateral triangle, P is any point on minor arc BC. Prove that PP plus CP is equal to P. Can we prove this? This is super easy, I promise. And once you prove that, told me you can come. I mean, once you prove that problem is couple. Okay. So what I'll do is consider a person X with maximum handshakes? How many maximum handshakes can be done? We have 9 people, they have done different handshakes. How many maximum handshakes can be done by a person in a group of 10? 8 one? It should be 9, right? But nobody can do handshake with the spouse. So 8. So possible handshakes, but we have 9 people who have done different handshakes. So number of possible handshakes has to be 0, 1, 2 till 8, correct? Right? So let X be a person with done maximum handshake, that is 8 handshake. To figure out who must have done 0 handshake.
Mr. Smith.
Mr. Spouse. And then,
Okay, can I prove the spouse of X have done 0 handshake? How? If I am saying some person X have done 8 handshakes, some person X have done 8 handshakes,
Mrs. Smith.
then
Mrs. Smith.
the person who has done 0 handshake must be X's spouse. That is not Mrs. Smith. Okay, let us check. Suppose this is X. X has done 8 handshakes. So X has done this handshake with whom all? He can't do handshake with himself. So he has done handshake with everybody. So let us show handshakes with lines. Okay? Except X's spouse. So Y is X's spouse. Okay? Y is X's spouse. Okay? So X must do 8 handshakes. So it must be with these 8 people except this one. Correct? That means these 8 people must have also done at least one handshake. So who is a person with 0 handshakes? Which is spouse of X. Correct? Can I just write H's? Or can I just write 0? Okay, is this clear? Is this clear? Now let us consider a person Z here who has done 7 handshakes. So Z must have done this handshake with whom all? Z has already done handshake with X.
so these people.
Can Z do handshake with what?
No.
Or let me call this as Mr. X and Mrs. X. Okay? And let me call this. So Mr. Z has done 7 handshakes. Can Z do handshake with Mrs. Z? No. So 7 handshakes Z has to do with whom all? He can't do handshake with here, here, and here. So he will do handshake with all remaining people. Right?
Why can't they do handshake with Mrs. X?
Because Mrs. X have done 0 handshakes.
So how did it finish?
So if Z does handshake with Mrs. X, then Mrs. X would have done at least 1 handshake. Right? Is that clear? So, can you tell me how many, which is a person who has done only 1 handshake?
Spouse of
Mrs.
When I am explaining, you will not disturb us. I have given you time to solve this. Now I am explaining, so pay attention. No group discussion. Ask to me, not to him. You can directly ask him. Now, here this. So what we claim is the person who made 8 handshakes and 0 handshakes are spouses. Person who made 7 handshakes and 2 handshakes are spouses. Correct?
6 and 3, 5 and 4.
7 and 1. Sorry, not 1.
And 6 and 2.
Correct? So,
6,
person
2,
who
5,
do 8 handshake and 0 are spouses, and 7 and 1 are spouses, 6 and 2 are spouses, and
5 and 3 are
spouses. So, only number of handshake left from Mrs. Smith is 4. Correct? Followed? Is that clear?
Ma'am, why can't Mrs. Smith be one of the first slide?
Okay. See, suppose I consider, we are considering people other than Mr. Smith, okay? And we know that all of them have done handshake from this 0, 1, all different handshakes, correct? I will repeat from the beginning because there was chaos, that's why you were not understanding. So, let X be the person, Mr. or Mrs. whatever, X be a person who has done X be a person who has done 8 handshakes. Then who must have done 0 handshakes?
Mrs.
Spouse. Correct? Because X has done 8 handshakes. So apart from his or her spouse, he must have shaken hand with everybody. So everybody has done at least 1 handshake. So only person who has not done any handshake is spouse of X. Correct? Only person who has not done any handshake is spouse of X. Correct? So they must be couple, so we can call them Mr. and Mrs. Okay, whatever. Okay? One of them is Mr., one of them is Mrs. Without loss of generality, we can call them. Next, we will take somebody who has done 7 handshakes.
Mr. Z.
Okay? Z. Now, Z want to handshake with Mrs. X because Mrs. X have done 0 handshakes, and he or with his spouse, his or her spouse. Correct? But he will do handshake with rest all because we want 7 handshakes. Correct? Rest all 7 people he has to do handshake. Correct? So all these 7 people have done handshake with Mr. X and Mr. Z. So they have done at least 2 handshakes. Correct? So who must have done single handshake? Spouse of Z.
Mrs. Z.
Okay? Followed? Is that clear? Similarly, you take a person, say Mr. T, who has done 6 handshakes. Okay? So he can't do handshake with this person, he can't do handshake with this person because they have done 0 and 1. So he has to do handshake with, and he can't do with his own spouse. So he has to do handshake with the rest all people. Correct? Okay? Followed? These are 6 handshakes. Correct?
Yes.
So who must have done 2 handshakes? Mrs. T, because rest all people have done at least 3 handshakes. Correct? Like this it will go on. So number of people who do 8 handshakes and 0 handshakes are spouses.
Spouse.
Number of people who do 7 and 1 are spouses. 6 and 2 are spouses, and 5 and 3 are spouses. Correct? Is this clear? Now we are counting from the set where Mr. Smith is not there. So can Mr. and Mrs. Smith contribute in any of these? No.
Yes.
These must be other 4 couples. So number of handshakes by Mrs. Smith is 4. Correct?
Oh, yes.
Is this clear? Huh? Any doubt? Yes? No, that we can't. That is not possible to do. Any other thing is not possible to calculate except Mrs. Smith. No, that cannot be. That doesn't work that way because Mr. Smith is not among 0 to 8. That's the point. Okay. Probably we can count it, yeah, because total number of handshakes should be even. I can't.
But one person can handshake with every person.
No, no, no. Without the spouse.
Without the spouse.
Okay?
So,
No, no, no. Multiple times. Only once. Huh? Okay? Is that clear? Huh? Any other doubt, anybody? Huh? Yeah, different number of match. It was given. Okay? Huh? Yes. Any doubt, anybody?
Multiple times.
Okay, so try this geometry problem. At least this much you have done. Yes. Is this visible?
Yes.
Is this visible? AB is equal to BC is equal to C. And DE is equal to EF is equal to FA. And angle ABC angle DEF is equal to 60 degrees. And angle C, this angle are 60 degrees. And these are what we need. So H and G are points in the interior of hexagon. Points in the interior of the hexagon. Such that CHD and AGF is 120. Then I have to prove that CH plus HD plus HG plus this is greater than B. Greater.
Today 3 periods max wins, tomorrow 3 times the question will come for max.
3 types of
3 times the question of
I'm not understanding.
No, ma'am. He's saying that there are 3 maths period, so the question will come 3 times.
अच्छा ये test
Ma'am, 3 subjects.
then I use one. I didn't give any test. Huh? No. If I give a test, then you will all cry. I'm really sorry. When I give a test, it is always a tougher test.
Ma'am, 3 chapters for
And so you gave a Mr. Spouse test.
Mr. Spouse, Mr. Mouse, Mickey Mouse, Minnie
Mr.
Mouse,
House.
Mr. Mouse,
Mouse क्या होता है? कुछ नहीं.
Mouse.
Oh, sorry, ma'am is informed for all the 3 sessions. There will be one test of 10 marks.
You only told him that.
I have not given questions. They are ready.
क्या है कन्नड़?
अरे 3 chapters के आने वाले सारे chapters Anna.
This year I started teaching to IIT level. When I don't teach to IIT level, I teach for INMO IIT. Okay. Usually I deal with not synthetic geometry. I deal with projective. There are many types of geometry. Transformation geometry, complex number, barycentric geometry, projective, inversive. Okay, these are huge geometries. Okay, and they are beautiful. Inversive and projective are so beautiful. Okay? Like, inversive is very beautiful because in inversive we can convert a circle into a line and line into a circle. As a result, many problems can boil down. Like, I mean, for Ptolemy's, I don't even remember the synthetic proof, it is very dirty. But with inversive geometry, we have 2 letters. So, try to study this topic. Oh, okay. Very good. Huh? I can't hear you. I love all the topics except algebra. Algebra, I polynomials, but not
I also
inequalities
love
and functional inequalities. I don't like because I've never done that. So Jafar is a culprit because he used to be always there for inequalities, so I never put my brain into that. Okay? But other three topics I love.
ये बोला ना किसी बुलाया
मैंने कहा
What do you want? Inversive. Inversive will take a little time. At least 5 minutes.
हम कल के टेस्ट में 3 चैप्टर था
I'm not checking it.
यार तू सोने जाके फिर सोन
Yes.
डिजिटल ब्लाउज है
Yes.
मिस्टर ब्लाउज के बाद में ये गाड़ी में जाके भी ब्लाउज करके दे जाएगा Very good spouse. Very good house. Blouse. क्या?
अच्छा लगेगा कुछ मन में नहीं तो पिंक
Okay. Let us first see, at least see this. Okay. Now, this is a cyclic quadrilateral. Yes. ACPB is cyclic quadrilateral. Apply Ptolemy's theorem. But before that, let me call sides of equilateral triangle as x. Yes. Okay. So PC into x or PP into x plus CP into x is equal to AP into x. Cancel x after. Is this clear? Yes. One line. Is this clear to you? Yes. Any doubt? Now, so are we ready for solution of this? Yes. Okay. So let us see. What I can do is, I have a triangle whose two sides are equal at vertical angle in 60 degrees. What can I say about this triangle?
Equilateral.
थोड़ा time और दे दूं? Okay, चलो. I'll give you a little bit.
अभी तो सोना है
350. What time?
ये will give me gold give me gold
Just give one more problem.
you are a very bad spouse
and have a very big blouse
you are disgusting spouse when you have blouse you are a very naughty spouse
Is this for Mr. and Mrs. Smith में बताया? So should I give a similar problem? Yes.
इसमें किसमें
Mr. and Mrs. Mr. spouse
Mr. blouse
Mr. House
Sorry.
मतलब क्या बोल रहे What? You speak good English.
you speak a very good
Suppose I have any 6 people in the world. Any 6 people. Okay? You already know it, so you are not allowed to give the answer. Okay? Any 6 people in the world, we can prove that there are 3 people who mutually know each other. What do we mean by mutually knowing? That is, A knows B,
B knows C
B knows C, and A knows. Either three people mutually know each other or three mutually does not know each other.
मैं तुझे नहीं जानता.
So among any 6 people in the world, any 6 people, okay, there has to be some 3 who mutually know each other or some 3 who mutually doesn't know each other. We have to prove this.
तीन
Okay.
न्यूबॉर्न बेबी फ्लो तीन एक
Prove that.
तीन न्यूबॉर्न बेबी चल रहे
In the handwriting, okay?
एक राजस्थान से और एक राजस्थान से उधर से और दूसरे से नहीं एक मुझसे बुलाओ
ये कैसे होगा?
Okay?
Ma'am, how can this
Be proved. This is not an IOQM problem. This is a RMO level, I will say. But in IOQM, they use this logic. Like last time. That's it. I don't remember number and all that. My memory is very poor, that's why I'm holding maths. I don't have to remember anything, I can create that.
अंतर है?
I prove it.
अभी मैम मेरे बायोलॉजी क्लास से अभी
Ma'am, how can this question be asked in RM? We prove वाले था.
That's why I don't remember that. Whether it is or not, but
Ma'am.
you can create that. Generate that.
Ma'am, how can this question be asked in RM?
Yeah. This is a proof.
This is a proof question.
In RMO, it's subjective. It's a 6 question for 3 years. You have to write 17 marks each.
Ma'am, 3 years.
3 hours.
Yeah.
17 marks each. Okay. So, is it okay if I tell that question's answer?
Yes.
Because I'm sure. Because last 15 minutes, that's it.
दो क्वेश्चन से एक
Well, last 5 minutes.
से बोलो लास्ट
Anju,
जो वापस मारना लेकिन
Anju.
Yes. What we'll do, see, pay attention. What they commented that in the Mr. and Mrs. Smith, they like the diagram.
That's not right.
He's right, that is not a diagram, but kind of a diagram. This diagram was first contributed by Sir Euler the Great when he solved a problem which was unsolved for 300 years.
प्रॉब्लम क्या
Okay? Achha, if you want that, let me rub this, then I'll show them. Okay? So he created this concept. If you are bored, I request you to leave the class. I'm okay. I don't mind a single person in my class who is interested. And if not even single person is interested, it's okay. I won't take it on ego or something. Okay? But if you are here, then pay attention. You will not disturb us. Okay? That. So, Euler first got the concept of taking some points for something and lines for relation between them. Like we took points for people, and if they have shaken hands, we were drawing them by lines. Correct? Such a diagrams are known as graphs. Okay? And here I'm going to solve this problem by using graphs. So for people, we will put points. So we have 6 points. Okay? And oh sorry, 6 points, and we have to draw lines between them. So if they know each other, let's color it with blue. And if they don't know each other, let's color it with red. So what I want to prove that among a graph with 6 points, either I have a blue triangle or a red triangle, correct? A graph with 6 points, okay, graph with 6 points, where edges are colored with 2 colors. Edges means segments, join.
Edges.
Edges
GE.
with 2 colors, red and blue. Then there exists either blue triangle or a red triangle. This is what we want to prove. Everybody agree? Yes. So what we do is we consider any vertex. Say this is my vertex, B1. How many edges are coming out from that? 5 edges, correct? So I claim that at least some 3 of them should be of same color. Claim at least some 3 are of same color. Yes. Because if not, I say no, no 3 are of same color. Suppose no. Suppose no. That means there are max to max 2 blues and max to max 2 red. So max to max 4 colored edges, but I have 5. Correct? So fifth will have some color, correct? Yes. Okay. So now what I will do is I will draw a graph. Suppose I will color them, and for sake of drawing, I will color randomly some 3 blue. If some other 3 are blue, similar proof will work, or some other 3 are red, similar proof will work. I'll show you. So I am taking some 3 of them one. Okay, some Vx, Vy, and Vz are blue. Suppose. Okay, then suppose any of this is blue. Suppose V1, Vx, Vy is blue or Vz is blue. Then we get blue triangle. I have to make many copies of this. I get blue triangle, and if in this case I get blue triangle. Suppose if this is blue, I'll get blue triangle. This is blue, I'll get blue triangle. This is blue, I'll get blue triangle. Suppose no, none of them is blue. Then what to do? They are not blue means what? They are red. So I'll get red triangle. Correct? So either I will get a blue triangle or I will get a red triangle. Is this clear? Is this clear to you?
Yes.
Now here I have not used exactly which Vx is blue, correct? So same proof will work if any other 3 segments are red. Can you see that? Or any other 3 segments are red. Can you see that? So here I have not taken a special case. I'm just using this to write the proof problem. That's all. But any other case will work similarly. Can you see that? Okay. So are we done? Is this clear? That one. 6 people.
for the equals.
वायर कैसे
नहीं निकाला
मेरे पेट में दर्द आता भी नहीं
उधर तक पैर इधर तक आ रहा है देखो स्टेलेटस लगा है बता के आपने
Yes.
And so can it be said for 8 people also that
Yes, any number of people greater than 6 will always have at least one triangle of same color.
and less than 6?
No, I can give you counter examples. Five people. 6 is the smallest such number. So anything greater than 6 will work for 4 people and for 3 people. These are counter examples that there is no monochromatic triangle. Can you see that? Huh? See, this is not a triangle. I have these 5 as vertices. Huh? Okay? Is this clear to you?
Yes.
Alright? So it doesn't work for 5 people, doesn't work for 3 people, doesn't work for 4 people. So 6 is the smallest, and more than 6 obviously for any number of people. But in a group of 6 it works than in a group of 7, 8. Rather, I can prove that there exists at least 2 monochromatics. Okay, try to. Huh? Sorry, 6 people. There are at least 2 monochromatics. Do you know how to? Okay. Is this clear?
Yes.
May I erase? Now, this is why this problem has some historical value. Because this created a branch of mathematics called Ramsey theorem. Okay? It is Ramsey theorem and okay, it is a wonderful, very beautiful branch of gravity. Okay, and there was a question asked in current last IPM on this type of argument. Question 19. Which I don't remember, he remembers question number 19. Okay, you can check it. Okay, so may I erase this? Huh? Okay. So I'll quickly finish with this problem because I need to discuss books also. Okay. So quickly I'll finish with this problem. Is that okay? Yeah. We know these two are equilateral triangle.
Yes, ma'am.
As a result, I will get AF is same as DF
Yes, ma'am.
and AC is same as CD.
Yes.
So what kind of quadrilateral is ACDF? Kite.
Kite.
What is axis of symmetry of this kite? CF.
Yes.
Is axis of symmetry?
Yes.
Reflect P point here,
Yes, ma'am.
P dash, and reflect over here. I will have BP plus CP is equal to reflect E here, E dash. This much is clear?
Yes, ma'am.
Any doubt, anybody? What can I say about this angle? This angle is 60, so what can I say about this angle? 60?
Yes, ma'am.
Do we get some nice configuration here? 120 and 60. What can I say about this? Cyclic quadrilateral.
Yes, ma'am.
And this is equilateral triangle.
Yes.
Equilateral triangle and cyclic quadrilateral. Okay? So distance of P from neighboring vertices, sum of distance of P from neighboring, it's same as its distance from. So what is length HC plus HT? Is equal to P dash, HB dash. Correct? Similarly here, what can I say? This is 60 and this quadrilateral is cyclic. Correct? Yes. This quadrilateral is cyclic. Okay? Therefore, GA plus GF is equal to GE dash. Correct? Alright? So what I have to prove? To prove that is equivalent with, to prove that what CH plus HD, CH plus HD. Okay? This I can replace by HB dash plus HG plus GA plus AG plus HG is replaced by GE dash. Yes. What is this? Let us draw and check. That is P dash H plus HG plus E dash. Correct? Followed? Huh? Correct? Yes. So this is a crooked line starting from B dash. From B dash I am going to H, from H I am going to G, from G I am going to E dash. Okay? Can I say this is greater than or equal to B dash E dash? Yes. Why? Because B dash E dash is a straight distance. Correct? Correct? Triangle inequality, everybody knows triangle inequality. Yes. And what is relation between B dash, E dash and B? Your wisdom. Okay? Followed? Is it clear? So some of the good geometry problems can be solved using reflection. Okay? So create what you want. Why I created this? Because I wanted to engage this plus this. I created this because I wanted to create a cyclic quadrilateral. 120 degree and 60 degree. How can you encash? Cyclic quadrilateral is a best help. 90% RMO problems. Cyclic quadrilateral has to be involved if they are not projective. Okay? Followed? Synthetic geometry.
Then out of 6 questions, how many questions are
geometry? RMO, yes, till they ask geometry. Okay.
1 to 2 questions?
Earlier it used to be one question each. 2 geometry, 1 algebra, 1 number theory, 1 formula, and 1 extra of anything. Either in algebra, copy or number theory. But nowadays geometry's weightage is reduced. Okay, in RMO and in MO. Okay. So I'll stop here. You want books? Then what I'll do? I'll share books with.
Yes.
Can I have 5 minutes? I'll just show the books. Or actually, I'm sorry. Okay. So I will share the books with and I'll write in detail for RBM what are chapters you should do, for RMO what are chapters.
Okay.
Okay.
Thank you, ma'am. बोल अरे जोर से बोल जोर से बोल जोर से
I'm Shauna Kaipur from class 10 from AC Sanapura, and thank you, ma'am, for this wonderful lecture. I'm very grateful to have you as our teacher.
Even I enjoyed this. This is a great class. Great students are here. We got enjoyed it, as I say. You don't know many things, but still you're solving problems and cracking problems. That is real. That is what is required for us. You will definitely do well in life. So all the very best. And if you have any doubt, you can approach.
और बोल ना
He wants to say something. Oh, sorry.
बोल ना.
Yeah, please go ahead.
At first, things were a little bit hazy, but after your wonderful explanation, I think I've got what I had to learn. That's
जोर से.
that's what I
Smiles.
Thank you.
Camera.
Oh,
Memo
I
accepted.
shared a document in geometry, especially how to prove things is difficult for you.